Hello viewers, I'm Kausalya. So today we are going to solve example 3 in chapter 13. So the problem is a wooden toy rocket is in the shape of a cone mounted on a cylinder as shown. The height of the entire rocket is 26 centimeter while the height of the conical part is 6 centimeter. The base of the conical portion has a diameter of 5 centimeter while the base diameter of the cylindrical portion is 3. Right. If the conical portion is to be painted orange and the cylindrical portion yellow, find the area of the rocket painted with each of these colors. Right. So here take pi as 3.14. So since the problem seems to be bigger, don't get afraid. Right. So this is pretty simple. Once you understand the concept, it will be very easy for you to solve. So here, what are all the different shapes do we have? So here we have a cone and a cylinder. Okay. Just highlight those two things. And what are all the given data? The height of the entire rocket, that is height of both cone and cylinder are 26 and height of the cone is 6. Right. And again diameter is given. So you see the conical diameter is 5 and the cylindrical diameter is 3. That's it. These are all the given parameters. And you see a wooden toy rocket is in the shape of a cone mounted on a cylinder. Right. So here we have a cylinder. So on the top of the cylinder we have a cone. Right. So first we will have our diagram. You see this is the cylinder. On the top of the cylinder I am having a cone. Right. So what are all the given data? You see the diameter of the cone is 5 and the cylinder is 3. It is clearly mentioned in the problem. Similarly, the total height is 26 and the height of this conical part is 6. This is also given. Right. So this is our diagram. We have a cylinder and a cone is surmounted on the cylinder. So here the thing is, again we have to find the areas that need to be painted. Right. So assume this is just like, even we can consider a table lamp. Okay, the same way. So here we have a conical part. So first we will finish off with the conical part. Right. So for the cone, what is the formula for the curved surface area? It is nothing but pi or L. So here L is nothing but slant height. Right. So as a first step, we start finding our slant height of the cone. So before that, just make a note of it. You see, let R and H be the radius and height of the cone and R dash and H dash be the radius and height of the cylinder. Okay, to avoid some confusions, because both the cone and the cylinder has the radius, right? So we are doing like this, radius as well as height also. So L is nothing but square root of R square plus H square, right? So here, right, this is the conical part and here the diameter is 5 centimeter and what about the height? Here it is 6 centimeters. So the dia is 5. So what about the radius? It is 5 by 2. So 5 by 2 is nothing but it is 2.5 centimeter. This is your radius part, right? So just substitute the value of 2.5 in radius and what about H? It is 6. So just substitute. So 2.5 square is 6.25 and 6 square is 36. So here when you add, I am getting 42.25 and when you take the square root here, we are getting the answer as 6.5 centimeters. Right. So now we are considering the conical part, because conical part we need to paint it in orange color. So area to be painted orange is conical area. So in this conical area, when you consider the cone alone, you see again consider the same thing. So here I am having this top portion of the cylinder, right? You see here I am having the top portion over here. So when you consider this total surface area of this part, what are all the things you have to include? You have to include this part, okay, cross-sectional area of the cone as well as here the base area of the cone, but this base area has this top area of the cylinder. So you have to subtract this top area of the cylinder. Right. Am I making sense here? So write down the formula like that. So it is cross-sectional area of the cone, right, plus cross-sectional area of the cone plus base area of the cone, right, minus here base area or top area of the cylinder, because this is a cylinder, right? I consider this as the base and this as top, right? So top minus top area of the cylinder, again this is in the form of a circle, right? So just write down the formulas as such. So instead of base, you write it as top area, okay? Top area will be perfect here. Let this be the base of the cylinder and let this be the top. So what is the formula? For cone it is pi RL, right? For the cross-sectional area of the cone it is pi RL. What about the base area of the cone? Again this is also in the form of a circle. So here it is pi r square because r is the radius of the cone, minus, and here we do have another circular shape and this is the top area of the cylinder. Again this is in the form of a circle. So here what is the formula for circle? The area is pi r square, and since for cylinder we have taken the radius as r dash, here I am writing it as r dash square, right? So in all these three terms we are having pi as common. So take pi outside. When you take pi, what about the remaining terms? Here it is RL, here it is r square, and here it is r dash square, right? So just substitute the values. Here in the problem, the value of pi, it should be taken as 3.14. They had clearly mentioned. Once they have mentioned, you should follow as such. So here it is 3.14. What about the radius of the cone? You see, it's better I could have drawn the diagram down. The radius of the cone is 2.5, right? What about the slant height of the cone? It is 6.5. So just substitute the values here, right? 2.5 into 6.5 plus again here this r represents the radius of the cone. So again the value is 2.5, and here r dash represents the radius of the cylinder. So here in cylinder 3 centimeter is the diameter, right? So what about the radius? It is 3 by 2. So radius of the cylinder is, even you can write, you see radius of cylinder, it is nothing but 3 by 2, which is equal to 1.5 centimeter, right? So just substitute the value as 1.5 here. So once you solve this, here we are finally ending up with the answer as 63.585 centimeter square. Right, so this is the total surface area of the cone which is to be painted in orange color. Right, so one part of the problem is over. Now we will proceed with the next part which is to be painted in, what is the color? It is yellow, right? So you see, just now we have completed the conical portion which is to be painted, right? So now you see here, next we have to paint this cylindrical portion with yellow color, right? So what is the formula to be used here? So you see here, to this cylinder we have to cover this entire surface area. So here the formula to be included here is total surface area of the cylinder plus, apart from that we do have a base here, right? So plus base area of the cylinder. So these are all the two terms which we have to include. Therefore, so cross-sectional area of the cylinder, curved surface area of the cylinder plus area of the one base of the cylinder, because that is the visible part, right? The top portion gets hidden under the conical part. So what is the formula? So here it is 2 pi r dash h dash, because we are discussing cylinder, so it is dash, plus pi r dash square. Again here pi r dash is common, so when you take, the remaining terms are 2h dash here and here r dash, right? So the value of pi is 3.14 and r dash is 1.5. Similarly h, the height of the cone, it is clearly mentioned, right? Wait. So how to find the height of the cone here? You see, the total height is 26. height of the cylinder. The total height is 26 and height of the cone is 6. Obviously, the height of the cylinder part will be 26 minus 6. Therefore, this is 20 centimeter. Right. So in this formula here, I am substituting this as 20. Right. So when you multiply 3.14 with 1.5, that gives 4.71, and this term gives 41.5, and finally here the answer is 195.465 centimeter square. This is the area which is to be painted in yellow color. Right. So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.